Hi everybody, we're going to be talking about algebraic expressions. We're going to be identifying parts of algebraic expressions as well as simplifying them. So these are the notes from 7th grade Common Core lesson 3.1. Everything we're going to be talking about is an algebraic expression, and an algebraic expression contains variables and more than one operation. So if I were to look at example 1, I'm going to say that 2r squared plus 7r minus r squared minus 9 is an algebraic expression because there are operations as well as variables. The first thing that I'm going to do prior to identifying any of the parts of the expression is I'm going to convert this expression into an addition expression. Now, this isn't required to go ahead and do, but it's easier to go ahead and see if the variables or the coefficients are positive or negative when I go ahead and change it into an equivalent addition expression. So I'm literally going to go ahead and when I subtract r squared, that's the same as adding negative r squared. And when I subtract 9, that's the same as adding negative 9. So I'm going to go ahead and switch that up right away. Terms. Terms are the specific parts of an expression. And I can indicate those by commas. So 2r squared is an expression as a term, 7r, negative r squared, and negative 9. Now, I want you to notice that the mistake that I typically see is that some kids, when they don't change it to adding a negative, r squared is a negative r squared. So it's important that you're including the negatives on both of those last terms. Like terms are terms that can be combined. They have the same variable to the same exponent. So if I were to look at those, r squared and r squared are like terms because their label that I call it, or that variable of r squared, is the same. So I'm going to say that 2r squared and negative r squared are like terms because they could be added. R and r squared are typically confused as being like terms, but because the exponents are different, they are not like terms. Now the constant. The constant stands alone, the constant stands alone. Hi-ho, the Cheerio, the constant stands alone. That means it's not with any variables. It's a lonely number. So if I were to look into this expression, my lonely number is negative 9. It has no variables with it. So the coefficient, it is in front. The coefficient, it is in front. It's in front of the what? Of the variable. So if I were to look at my terms, and I have to look at terms that have a variable in it, and the only terms that have a variable in it are the ones that I'm going to list, but I'm not going to list the whole term. The coefficient is the number in front of the variable. So 2 is in front of the variable, 7 is in front of the variable, and there's a negative in front of the variable. So the coefficient is 2, 7, and negative 1. So let's talk about where that negative 1 came from. If I have the variable x, that means I have 1x, so the coefficient is 1. If I have a negative x, that means I have 1 negative x. That means the coefficient is negative 1. So when I'm looking at coefficients, I'm looking at the numbers in front of the variables of a term that has a variable in it. All right. So you need to be familiar with this vocabulary and be able to identify parts of the algebraic expressions. In the next part, do the same thing. So what are my terms? I have a 7, I have a 4p. Oh, look, I have a negative 5 because I changed it to an equivalent addition expression. I have a p and I have a 2q. And I did that by separating them by commas. Now, like terms, those are terms that I could add. So I can add a 7 and a negative 5. And I can add a 4p and a p, like terms. Constants. The constant stands alone. The constant stands alone. Hi-ho, the Cheerio. The constant stands alone. No variables. 7 and negative 5 are constants. They stand alone without a variable. The coefficient, it is in front. So in front of what? The variable. In front of the variable. In front of the variable. In front of the variable. I have a 4. I have a secret 1 that's not there, but I know it's a 1. And then I have a 2. You need to be able to identify these different vocabulary words as parts of an expression. Now let's move on to simplifying expressions. I'm going to go ahead and zoom in a little more for this one. Now, If I were to simplify algebraic expressions, I can use distributive property to do that. And the goal is to combine like terms. So as an expression is simplified if there are no like terms and there are no parentheses. So in my first problem, example 3, I have to look and, all right, I'm going to change this automatically, this -5 to adding -5. I like this circle square method. And what I'm doing is I'm circling up like terms, and then with other like terms, I'm squaring it. So I visually can see that these are like terms. So I have 2.5x's and 4.2x's. That gets me 6.7x's, and then I have a -5. Now, because I want to make sure that I'm adding things correctly, I do plus -5. But when you're simplifying, if I have adding a negative, I need to take it a step further and move it back. So my actual answer is 6.7x minus 5. Now, I know you may think that this is a wasted step. And in this example, it's to visually see it, but there will be other numbers in which you're going to have to do the operation, and it'll make it easier. Typically in algebra, we see that the variables are going to come before the constants. So my circle square method is a way for me to visually see the like terms that I can go ahead and add. In example 4 and 5, before I go ahead and do any circling squaring in order to combine like terms and identify what terms I can add, I need to use the distributive property. And in this distributive property, I multiply the coefficient in front of the parentheses by every single term inside the parentheses. So I am not going to be multiplying anything because it was minus. So I'm going to multiply it by -1/4 because I need to write an equivalent addition expression. So -4 times 3/4, that's -12 divided by 4, -3x. -4 times 1/4, so 1/4 of 4. 4 divided by 4 is 1, and then it's a positive. All right. So if this is something you're really struggling with, the computation, if you need to do -4 times 3/4, oh look, it's -3, that's okay. If you need to doodle to the side. If you need to do -4/1 times -1/4, oh look, it all canceled out, that's +1. That's okay. Just do it to the side. In example 5, I not only need to use the distributive property, I am then going to have to combine like terms. So 3 times the quantity at q plus 1 is 3q plus 3. Some kids are going to forget that that's a 3. It's not a 1 and forget to multiply. 3 times q is 3q. 3 times 1 is 3. Because this really means I have q plus 1 3 different times. And then I have this, which I'm going to change to, rather than subtract 4, add -4. So I have a 3q with no like terms. I have a 3, and I have a -4. Well, I can combine 3 and -4. So I have 3q plus -1. Now, I'm going to go ahead and take this a step further and simplify it because adding a negative is the same as subtracting. And so I have 3q minus 1 is my simplest one. So the strategy I'm using here is getting rid of any parentheses by using the distributive property. And then I like my circle square method in order to go ahead and visual as to go ahead and be able to see like terms. You need to know the vocabulary. You need to be able to identify parts of an expression, and you need to be able to simplify an expression. Everything I wrote down, you need to write down. If there is something you do not understand, I would expect notes on the side for questions when we review in class or shooting me an email. Just going ahead and copying down the notes and not having a clue what the heck I'm talking about is doing you nothing, all right? That is not doing the homework. You need to understand what the heck I'm talking about. So if you don't, you need to make sure you're coming prepared with what specific things you do not understand. If you want to go ahead and make sure that you're even doing more, you could go ahead and go on YouTube. You could go ahead and go to YouTube and write down identifying parts of an algebraic expression, and someone else will explain it. All right? So please be an advocate for yourself and do more than just copy down the notes. Have a clue as to what the heck I'm talking about. Thanks, guys. Have a good one.